Next we have white blood cells. Remember, technically called leukocytes, so literally translate means white cells. We can identify white blood cells in two ways. One is by the size and shape of their nucleus. These do have a nucleus, unlike red blood cells. And also a staining method, in which, depending on if they have spots on them or not from that staining method, and the color of those spots. There's two types of white blood cells upon the staining method called granulocytes. These are cells that will have little granule appearances, sometimes big splotches, sometimes little pepper dots, and this accounts for most of them. There are three types here. The neutrophils, also known as polymorphonuclear, meaning that their nucleus has many shapes to it. Characteristics: polymorphonuclear. It has a 5-portion nucleus. And what we see here in the middle, okay, these will have a pepper dot appearance with blue and pink dots. So it has a granulated appearance. And notice, okay, here's one little blob of a little piece of nucleus, and that's attached to this second one, attached to this third one, little link here, the fourth one, and a link to the fifth one. Some of them have a 5-portion nucleus, although sometimes the way they're laying it looks like fewer, but it's always a 5-portion nucleus with the pink and blue, and therefore giving kind of like a purplish dotted hue. Their function: they're mobile, they move around the body, and they're phagocytic. They can engulf things size of a bacteria or smaller, so bacteria, viruses, and some poisons. Eosinophils. Eosin means sort of a orangish red color. Characteristics: it has a bilobed or a 2-portion nucleus. Okay, we see that here in the second one. Kind of looks like a dumbbell or like sunglasses. Some say, depending if it's flipped upside down, Mickey Mouse ears. So here's a big lobe of the nucleus and a connection to another big lobe. And this will have large red blotches on the surface from the staining method. So real characteristic: looks like it has measles or mumps. That's an eosinophil. Its function is weakly phagocytic. It can actually work on parasitic worms, slowly kind of munch them up. Now, it also controls inflammation, especially if you happen to be one of these allergy sufferers. This is one of the two that you blame. These will misbehave to a non-harmful particle and get you to react as if it's harmful. So again, gives you allergies. Very few of these are actually eosinophils. Basophils are the rarest of these, less than 1%. They also have a bilobed nucleus, 2-portion nucleus, as we see here on the left. And it's kind of hard to see, but it's in there, because these get big blue or black splotches on it. If all you see is something that looks like that it's been, burnt, kind of looks like a burnt out cell, then that's a basophil. Very rare. Now these secrete heparin, which is a clot inhibitor. These can secrete histamine, which is a vasodilator for inflammation, again, allergic reactions. Now, there's a group of cells called agranulocytes. Remember, anytime you put A or N in front of a word, it means without or not. So these are without granules. When you stain these will not form any kind of dots or spots. Monocytes, or once these are fully mature, macrophages. These are the largest of the white blood cells and have a very large nucleus, which will be irregularly shaped. We see these over here. Now, a lot of times they'll have this kidney bean shaped little curved nucleus. This is not the same magnification. These would be a lot larger cells, those compared to the red blood cells. And once he's mature, though, this can change from that bean shape that we characteristically see to, it can be like a star. It could be bilobed. It could be all sorts of different things. Macrophage is when they fully mature, and phage stands for phagocytosis. Remember, cellular eating, macro large. So basically these are called big eaters. These are largely phagocytic. They go around eating up anything that's foreign. cell debris, invaders, bacteria, viruses, parasites, anything. These are mobile. Diapedese is a process. These walk around like little amoebas, and they can actually crawl between cells. These do not have to be carried in the bloodstream to an infection. These can make their way through a tissue to an infection. Even virally infected cells give off a signal that will attract them, and that's called chemotaxis. They will follow a chemical trail, somewhat similar to if you hear that there's a fire, big fire nearby. How are you going to find it? You look for smoke, and you follow the trail of smoke. As you see a big cloud of smoke, and you look to where it's more concentrated, more and more concentrated. It's coming from the source. That's how you find the source. That's how these find an infection. Bacteria give off waste, unique to the bacteria, that you don't give off. It kind of senses that and then follows the trail. As it gets stronger and stronger, it makes its way through the tissues, like following the chemical trail. That's called chemotaxis. Cells that are infected with viruses, those cells will give off special signals telling the macrophages that they have been infected, and that will attract the macrophages. They'll eat up the viruses as they leave the infected cell, but also those cells will also attack the infected cells to keep the infection from going, or keep growing. Last one is lymphocytes. Now these are slightly larger, here on the right, slightly larger than the red blood cell. They're mostly nucleus, a little halo of cytoplasm on the outside. Now there's two types. There's B cells, and these are the antibody producers. Those protein smart missiles that track down specific pathogens, a certain strain of bacteria or virus, and help to remove them from infecting the body. And also T cells. T cells coordinate the attack of your immune system. These are the generals. They tell the other white blood cells what to do and when to do it in order to coordinate the attack against a pathogen, an infection. Now, each of these I've given you a normal range. I don't want you to really memorize that, but I do want you to understand which ones are the greatest, the lowest. So neutrophils are the most abundant, as we see. And then the lymphocytes. Then, of course, the monocytes. Then the eosinophils. And, of course, as I said, the rarest ones are the basophils. We do know the range normally for each of these. And, of course, each one of these, like the different types of military, will fight off different kinds of attacks, as I've sort of mentioned. It's more complex. But, of course, when you're fighting off one type of infection, that type of white blood cell that fights it off will also increase in numbers. And we can use that to create what we call a DIF, differential white blood cell count. If you count the first 100 white blood cells you see and you categorize those according to neutrophil, eosinophil, basophil, macrophage, and lymphocyte, the one that does not appear in the correct range, if one that's more abundant, well, that's a type of infection you're fighting off. So if you have a new unknown infection, like when they first discovered SARS, they had the same symptoms but a new disease. And since the types that fight off bacteria were increased, okay, so we know it's a bacterial infection. If it was eosinophils, it could be a parasitic worm. Or again, you can have people with allergies. But if you're looking for an infectious agent, you're looking for a parasitic worm. So this can help you in diagnosing new diseases. White blood cell counts normally range from 5 to 10,000 cells per cubic millimeter. Of course, if they go above, that's called leukocytosis. Normally it means you're fighting off an infection, and that should come back down to normal. Or, of course, you have a type of leukemia. Cancer in the red bone marrow will produce too many white blood cells. Or even as you get older, there's a type that, again, when you get older, you don't maintain homeostasis as much. And so white blood counts start going up a little bit higher, a little bit higher. Usually not what kills the patient, and of course does not cause too much harm, but it's not that great for you. sometimes your white blood cells get overly active and start attacking your own tissue, as we'll talk about later. My grandmother had that starting about 73, and she lived to be 93, so it did not really limit her life much. Leukopenia is when you have too low of a white blood cell count, and of course that hinders your ability to fight off an infection. Something like HIV also causes that, where it attacks actually white blood cells in order to remove them. And I don't know if it's not really, it's designed that way, it's not choice. But if it attacks the white blood cells, of course, it lowers the white blood cell count so the body cannot fight the infection as well. But usually a patient doesn't die of HIV, it dies of a cold, the flu, pneumonia, etc. Platelets, remember called technically thrombocytes, usually range 130 to 360,000 per cubic millimeter. These are little cell fragments that break off from the bone marrow. These last about 10 days. Little fragments, and of course, they'll rupture. These actually are now these days considered about the wonder drug. They help in patching up little leaks, but also they help in repairing those leaks. And they're starting to use them in all sorts of different research as far as stimulating response to surgeries, to help healing, a little bit of regeneration, fighting off cancer, all sorts of things. They will release serotonin, smooth muscle contractions, so that in blood vessels, muscles will contract, lessening blood flow through an area that does have a leak. So it makes blood loss decrease, and also basically makes it easier to make a patch.